Today, in chemistry, we are going to be looking at the ideal gas equation and how to apply it to solve problems. Now, that is the ideal gas equation here. PV is equal to nRT. That is the ideal gas equation. Here, pressure is represented by letter P, where the unit is atmosphere. The pressure must be measured in atmosphere to fit into this equation. So P stands for the pressure measured in atmosphere. The volume is represented by V, and the unit in this expression is the mK. Now we have N that stands for the number of moles present, and of course I know you know how to calculate the number of moles from number of moles is equal to the mass of the substance all over the molar mass. So that is how we get that one. So that if the mass is given to you in grams, you need to convert it to number of moles before it can fit into this equation. Then, this R stands for the molar gas constant. R stands for the molar gas constant, and it is measured in what? Atmosphere, dmg, per Kelvin per mole. The temperature is measured in Kelvin. So, in that case, if the temperature is given to you in degrees Celsius or degrees Fahrenheit, you have to convert it to Kelvin before it can fit into this equation. And of course, you know that PV is also an energy term, which means that nRT is also an energy term. So I can equally give the value of R as those per Kelvin per mole. That is PV is equals to nRT. Then we can make R equals to PV all over NT. That is how the units is derived from atmosphere dmg per Kelvin per mole. So that is how we get that. I have a question here which we are going to solve, and possibly that one will help you to understand how to make use of the expression. Now, the example here says that at the pressure of 2 atmospheres, the gas occupies a volume of 200 centimeter cube. If the temperature of the gas is 150, I'm sorry, this should be degrees Celsius. Now, if the temperature of the gas, after full stop, is 150 degrees Celsius, calculate the number of moles of the gas present. They have been given area to equal to 0.082 atmosphere dmg per Kelvin per mole. So we are now going to solve this problem. Solution. I've been given what? The pressure is equal to 2 atmosphere. So the unit is correct. We don't need any conversion. In case you are given in another unit, then it has to be converted to atmosphere before it can fit into this equation. Then we have our volume here in what? Centimeter cube, that is 200 centimeter cube, which we have to convert to dm cube. 1000 centimeter cube is equal to 1 dm cube. So we simply convert this one to dm cube by dividing it by 1000. That is 1000 EM key, which is equal to 0.2 EM key. Then we have our temperature given to us in T is equal to, what is that? 150 centimeter cube. 150 degrees Celsius, sorry, which have to be converted to 150 plus 273. My answer is now in Kelvin, which gives me, what is this, 423, 423 Kelvin. Let me check, 150 plus 273 gives me 4 this. And so, the R is given to us as 0.082 atmosphere EM cube Kelvin per mole. So let's write our equation down. PV is equal to nRT, and let's substitute for the values given. Or let's make N is equal to VV all over RT. That gives me P, 2 atmosphere, multiplied by PV is 0.2 EM key all over R, 0.082 multiplied by the temperature in Kelvin. So we have our answer in mole. I hope it is clearly understood this way, and I expect you to use your calculator to evaluate this and give me the answer in our next class. I hope this one is enough for you to go and solve a problem from your textbook or your past lesson. Thank you for watching. We meet again. Have a nice time. Goodbye.